You guys danced really well. I liked all of you guys' participation and your stretching. Hopefully, you guys are lit enough to understand React Lifecycle and Hooks. Right, guys? All right, I'll hand it off to them.
All right, now that we're all stretched out, let's continue with the lecture. We're gonna go more into depth with React, and we're gonna specifically go over the concepts of component lifecycles and hooks. Now, these two are very critical to understanding React, and you'll probably see them come up when you're actually developing your own applications. So let's get into it. But first, we're gonna do some review on some components, state, and React. All right, so this first part, it's more kind of a design question and idea. So when should you break a component down into smaller parts? There are three main motivations and three cases where you might do this. And the first is if the component code is getting too long or hard to read. So some real life examples of this might be if you're building a house. Say you're an architect or an engineer and you want to make a whole house plan, and it'd be kind of silly to just do the whole house plan in one single piece of paper, because then it'd get too large, too many details. It's not really going to make sense. So instead, you might rather prefer making a plan for each individual room. In React, the React equivalent of this is when we turn the navbar code all into just one React component, because we already have a lot going on in app.js, so we don't want this additional piece of code to clutter our code editor. The next case is if the component contains parts that we can reuse and they have their own functionality. So think of a shopping mall. A shopping mall has a lot of stores, and each one has their own set of staff, merchandise, etc. It's all universal. They all have these properties. So it makes sense to make this into a general reusable component or template. And then our React equivalent is with the profile component that we made in the last workshop. Because we have this, we can now generate or display multiple user profiles. And then the last case is if the component is already handling too many responsibilities. Think of an organization and leadership. You don't want to delegate all the roles and responsibilities to one person. Instead, you might just break it up into specific roles. For WebLab, we have academic chairs, we have the treasurer, we have the operation chair. We don't make our president do every single thing. And in the React example, the profile component already displays the user information. It's already doing all of that. So that's why we might want to make a separate cat happiness component to just kind of separate that logic and encapsulate it. So there is no correct way to structure a React application. There's no universal truth, but the decisions you make while structuring will eventually help you or harm you later down the line. So if you do this wisely, you can make design choices that make it easier for you to go about your application and programming it. So yeah, that bit was just for the future when you are actually designing and coding your project. Okay, let's do some practice with state and props as you've learned today. So we'll begin with state. Remember, this is the syntax we use and how it actually looks like in code. First, we always have to import useState. It will complain if you're trying to use the function when you haven't even imported it. And then to actually define a state, this is the line of code here. Here, the blue value, this is our actual state. And then the yellow value, it's the handler function for us to actually update the state and set it to actual values. Again, you never want to directly assign it. And then here, we're actually calling the function we imported from the React library. And the argument we pass in is the default value that the state initializes to. So yeah, these are just comments on what I just explained. So here are some examples of what it looks like in code. We have three states here. Persons, which is initialized to an empty array. We have pets, also initialized to an empty array. And exists, which is initialized to a false value. So yeah. All right, how do we modify state? Again, never directly assign state. This won't actually update it. Always, always, always use the set function that we define when you first define state. Okay, now let's see some examples of updating state. Here, we're updating a state called exists, and we're updating it to be true. Now let's see something more tricky example. If our state is an array, you have to be careful and make sure you're not just updating it to the new element. Remember, you want to maintain all the pre-existing information in the array, so you want to use the concat function. And this just keeps all the old values currently in the pets array and then adds on the new element you want to do. So another way to do this is called object destructuring. It looks like this. When you have 3 ellipses or 3 periods before your array, this takes apart or unpacks all of the values in the array, and then we have a comma to add on our new object. And this is all wrapped in a new array with these brackets. Okay, any questions about that review? I believe like that's part of the reason why this is illegal and why they want you to use the set function instead, because I'm not sure the exact nitty-gritty details of the state implementation, but do you know? All right, Calvin's gonna take this question.
I'm pretty sure it's just a special object that is like a pointer. So the thing value is like kind of just like a pointer in C or C++ if you've worked with that. So when you set it, you're just setting the value at that pointer. Whereas if you do something like this, then it's just resetting the pointer to something else.
Does that make sense? Okay, any other questions? Great, let's move on. All right, so kind of more onto the design choices you'll be doing with your application. Now let's explore components and where you would actually want to store state within your components. All right, what does that mean? Well, let's go over it with an example. So now we're on Twitter instead of Facebook. And let's say we're on this page here where it displays tweets. Let's say that right now we want to switch tabs to, instead of showing this post tab, we want to switch over to our likes tab. So let's kind of break down this web page into the components and how we might actually do this. So over here, we have the overarching component feed here. And within feed, we have 2 child components, tabs and tweet panel. And these components have 2 states. Tabs has the selected tab state, and tweet panel has the content type state. So this state for tabs, it's just whatever the user selects on the tabs. Kind of circular or repetitive there. But tweet panel, the content type state, it uses that to decide what kind of tweets to display. So the question is, how can we change this such that tweet panel updates what it shows based on what you select in the tabs? All right, so stare at this code and then talk to the people around you. This might look like a lot of clutter and gibberish, but we've highlighted the main pieces of information here. Again, it's just these 2 components have these states. So then how can you restructure this so that it implements the feature that we just talked about? So I'll give you guys a minute to kind of think about this. Feel free to talk to the people around you, and then we'll come back. All right, I think that was a minute. So does anyone want to share and volunteer what they think? fine. Oh, yes. No worries. So the solution to this is we actually move the states up into the parent component. So now that it's shared. So what does that mean? Right, let's look at the code here and notice that the two child components no longer have their states, and instead we moved it up to the feed component. So why would we do this? Interestingly, we can actually pass down the setter function and the state as props to other components. If you look in the feed component and then the tabs, we're passing down both the state as well as the state setter as props. So now if we go down to the tabs component, we can actually use those two props. And this is interesting and fun because now we can update state even if that state isn't in our component. So we can call on the setter function in tabs and update the state up in feed. So now tabs can handle that functionality. It can update the state to whatever tab the user selected, and we can then pass that updated information to the tweet panel component. So that's what we're doing here. We're passing that state as a prop to tweet panel as well, and we're passing it down as content type. So now in the tweet panel component, we can call on that prop to actually decide what kind of tweets we want to display. All right, maybe that was confusing. It's a weird flow of information, so are there any questions with that? As always, you can go on weblab.is/questions. Yeah. Um, yeah, we should probably clear that up because it is confusing and we're using different syntax. But the reason why we don't need to do props dot is because notice how this is defined in brackets, in curly braces. So that's actually unpacking props. So that's why we don't need to have that prefix. Does that make sense? Yeah, it's like the idea of unpacking and destructuring. Okay, any other questions? Great. So you'll see this come up often, and you probably have to do it in your own application, where if two components or multiple components rely on the same state or piece of information, you're going to have to move that state up into a shared parent component. This way, this allows you to pass that information down to all components that need it as props. So again, you can also pass down the setter function as a prop as well, and this allows you to update state even if it's not in that component. So now with this, we can switch between the tabs on Twitter and display the corresponding and appropriate information. Okay, so if that example was confusing, we have another one for you. So if you look at the component tree here, we have a parent component. We'll just keep it general and vague. But it has two children components, profile and feed. So profile has a state called blocked users, but the thing is, we realize that the feed component also needs this piece of information. So how can we do this? It's the idea we just talked about, but we move that state up into the parent component, and with that, we can now pass it down as props to the two children components that need it. So since profile was the component handling the actual updating of the state, we'll also pass down the setter function as a prop. And remember, feed also needed that information, so we'll also pass that state down to feed. And the reason we do this, maybe you think it's kind of roundabout, but it's because we're not allowed to pass information across sibling components. Remember, props can only go down from parent to child. It can't be child to parent. It can't be sibling to sibling. All right, so any questions there before we move on? Great. Let's get some more practice with props then. So let's continue with our Twitter example and break down the page that we see here. So everything is within the app component, that's the root one. And within that, we have all these nitty-gritty details, the nav bar on the left, feed in the center. with all those tweets that should be showing. And on the right-hand side, you have your trending, you have your suggestions, all that good stuff. So here's a exercise or a little question for you guys. Think about this question in terms of the feature itself, like not the code. But with this, what information should you be passing down to these 4 components in order to implement those features? So like for example, I'll just give this one away, but for the feed, you'll need access to all the tweets that you should be showing. That's one example of a prop that tweet or feed needs, and that's one prop you should pass. So kind of think about that for all these other features, all these other components, and here are your options here. So just think about that for a few seconds. All right, this is multiple choice. Raise your hand if you think it's 1. Okay, raise your hand if you think it's 2, 3, and 4. Great, so these are the answers. And TBH, you can make a case for any one of these answers. The motivation for passing down props to components is if that component needs that information. So if we think about these features and what information they need, well, the feed, as I said, needs information about the list of tweets. It might need information about the blocked users and who you're following in order to think about what tweets it should actually be showing you. As for trending, I don't use Twitter, but I'm assuming it needs the following and followers information, so it can show you what relevant tweets are trending. And then for the suggestions, these are suggestions of users that you should follow, so it needs access to those you're already following, those that follow you, as well as blocked users, because it doesn't want to suggest people you have blocked or people you already follow. So yeah. All right, here's another question. Now, instead of what app should pass down, what should suggestions pass down as props to the profile component? Kind of same frame, but think about that for a few seconds. All right, raise your hand if you think it's blocked users. Raise your hand if you think it's list of tweets. Followers. Following? Okay. So those of you who said following, that is correct. Again, I would allow it if you said blocked users. I think that's important to know as well. So this is just kind of like an exercise to get you thinking about design choices and letting you think about what information does a component need, and then that will be the deciding factor of is it a prop. So yeah. All right, let's compare the differences between state and props. So for state, state is maintained by the component that it's defined in. It's mutable, that means you can change it, and it can be updated by either human inputs or computer inputs. State allows us to have control over what we actually display in the application. On the other hand, props aren't maintained by the component. They are passed down and receive it as input from its parent component. They are immutable, you can't change it. The parent only reassigns the prop, and it can be updated whenever, again, the parent reassigns or passes in a new prop. So this prop, the power of props, they allow us to create reusable components and kind of turn a general component template into actual features with specific values we want. All right, any questions about that? All right, let's move on. Okay, so let's get into new content today and actually learn about the React component lifecycle. So note that there are 3 main phases to the lifecycle: the mount phase, the update loop phase, and the dismount phase. And then let's actually talk about what happens in each phase. Also, the component can get stuck in the update loop for an indefinite amount of time until it dismounts. But let's start and talk about with the mount phase. So we're going to make a restaurant comparison example analogy and think about the life cycle in those terms. So the first step in the mount phase is the trigger step. So this trigger is whenever the component is first called. This is the initial mount. In our kitchen example, this is when the customer first orders a component, and then React takes that order to the kitchen. And in the kitchen, this is the next step. Step 2 is the render step. In the kitchen, this is where React runs the JavaScript, where we define the component code, and as well as all these subcomponents, and it will return that rendered, compiled code back to React. For the third step, when React can put this JSX into the HTML DOM for the viewer to see. Now, DOM is a new term, but we'll be going over it in this lecture in a bit. But just know that this is the high-level idea of how component lifecycles work. Yeah. So parent components, when they render in the second step here, that also acts as a trigger for the children to render as well. So that is what the mount phase looks like. Let's see an example to further cement our understanding. Here we have an example website of WebLab's steak restaurant. So let's click on the order steak button here, and it's going to render us this steak component. So let's actually go over what just happened here and break that down. So this is the whole steak component. As soon as we click that order steak button, that was the trigger, and it called the steak component for the first time and renders it on the website. Or let's roll back a bit. So the render step, this step, React actually runs all of the JavaScript code here that defined the steak component, and then it shows it on the website in the commit step. All right, any questions there? Cool. Okay, now let's move on from the mount phase into the update loop phase. So this is what it looks like, and notice that it kind of involves the same steps, except the trigger here is different. Instead of the trigger being our initial mount when the component is first called, in the update loop phase, our trigger is whenever a state changes in the component. So back to our example, here we're updating our state, the doneness state. So this is going to be a trigger for a render. So yeah, kind of just what I said here. Since we clicked that button, it called this function here, and it's updating our doneness state, and that is a trigger for the component lifecycle. So now it will undergo these steps again. There is a trigger, and now it's going to render, and then it's going to commit. So yeah, that's why we kind of think of this as a loop. You're just in this update loop whenever the state changes. All right. So here's a little aside. Note that state is the only memory for this component. Every time you go through the render phase, all these lines are called again. This means that variables that are not state don't persist past a render step. All right. So let's move on to the final phase of the life cycle, the dismount phase. So this one's quite simple. All it means is that the component is no longer rendered. So back to our example, let's say that we cook it enough times until we eventually burn it, and we don't really want the steak anymore, so we're going to click the delete steak button, and it's going to make our steak go bye-bye. So what's happening here is that the component is dismounted. All right. So that was the high-level idea. Don't worry about the code too much, but just understand that. So overall, this is what the life cycle looks like and the steps involved. The mount phase, the initial mount is the trigger, and then it's going to do the render and commit, so you can actually see it on the website. And then it moves on to the update loop phase, and in this one, it's just going to stay there each time the state changes, which will act as a trigger for it to be rendered again, until eventually we reach the dismount phase. Now, dismounting, this just means when the component is no longer rendered. So if you exit the website, if you click to a new page and then that component's not a part of it, it dismounts, it's no longer displayed. Okay, any questions about component lifecycle? Okay, let's move on. So notice that we used the term DOM earlier, but we didn't really define it, so let's actually do that now. So DOM stands for Document Object Model, and it's a model structured as a tree, and it represents the HTML document, so like the HTML file, as a tree of objects. That's kind of confusing in a bunch of words, so let's break it down. So D in document, this is just the entire web page. It's the HTML file. An object, so in the DOM, it treats each HTML element that is rendered as an object. And then model, it just is a visualization so you can understand the structure and contents of the HTML page. So why is the DOM important and where does it actually come up? Notice how, recall that we use onClick or onSubmit attributes in our HTML elements, but how can we actually mix JavaScript and HTML like that? The answer is with the DOM. Because we treat these HTML elements as objects, this allows JavaScript to actually interact with them. Now, you can search up the nitty-gritty details if you want on your own, but this high-level idea is important enough because React kind of handles all of that for you. So yeah, the React virtual DOM. So that was the HTML DOM. React actually has and maintains its own DOM. So we call this the virtual DOM tree, and it represents, again, kind of the structure of your UI here. And the way that it builds its virtual DOM is it recursively renders each component, starting from the root until you get the whole tree. The reason we call it virtual is because it's not the actual DOM that we see on our browser. And we'll get into the differences soon enough. All right, now let's relate this back to what we just learned about component lifecycles. So in the first phase, the mounting phase, this is when the component is first initially called. So in mounting, what you're actually doing is you're adding this component to the DOM for the first time. Then you move on to the update loop phase. Now remember, updating is just when there's a trigger that causes the component to re-render. Example of a trigger is if the state is updated. So see in the image here, we have this component here, and then something happens, its state is now purple, so it re-renders. And again, you can stay in this for a while. And so eventually, we hit something that makes us dismount. And dismounting is the process of removing a component from the DOM. All right, so here's a question for you guys to check your understanding. First, what is the first step in both the mount and update phase? Any answers? Yes. You are correct. The answer is trigger. Right, let's move on. Let's see some more triggers. All right, so we've talked about this. The first trigger is the initial render of the component. And this is when, like, for example, you first open the website or you open the page. And also, if you remember, we had ternary statements earlier. That's called conditional rendering. So that's another use or example of the initial render. So again, we also mentioned that another trigger is if one of the ancestor components renders. This will also trigger all of its descendants, all of its children components to also re-render. Third, we also talked about this. A third trigger is if the state changes in the component. And another one is if the prop passed down from the parent changes. Right. So those are all the triggers that you should know. All right. So next question is, how do you create the virtual DOM at each phase? Any answers? Yeah, I don't like this question either, but the answer is rendering. So remember, the virtual DOM is the DOM that React creates, and it creates this DOM every time we do or undergo the rendering step. So we've talked about rendering a bit, but rendering is just when JavaScript, React, it runs all of the code within the components function, where components are just JavaScript functions. And then this triggers, again, all of the children's to be rendered, etc. So here's a scenario. Imagine a state in this component, inspiration generator, changes. And this will trigger the component where it resides to re-render. But again, remember if a parent component re-renders, this will also trigger the children to re-render. All right, so that was trigger, that was render. Let's talk about commit. During the commit step, React, how the virtual DOM and the actual real HTML DOM interacts is that React looks at the differences between its own internal virtual DOM, and then it compares that against the real DOM. So real one, virtual React one. Finds the differences, and then from those differences, it will only modify and commit the changes to the real DOM. So that's kind of how it interacts. It looks at the differences, and with those changes, it will actually commit only those to the real DOM. All right. Any questions there? Yeah, so this occurs, I'm trying to think if it occurs in the commit step or the render step. I believe in the commit step is when it actually makes that comparison between the two DOMs. And then after seeing what differences there are, that's when it actually updates the real DOM with those differences. Yeah, right. Any other questions? Okay, let's move on. All right.
Okay. Hello again. I'm going to be going over React hooks. So React hooks are specialized functions that allow you to hook into your lifecycle features. So the best example that we've already seen all across what we've been doing so far is useState. So useState allows us to control the lifecycle of the component by telling it to re-render. So you do the state update, and then that's the trigger, and then it re-renders. But let's see this example. So what do you guys think this function's going to print when it runs? So A or 1 for just nothing inside the brackets, and a B with the brackets having me inside. 1 or 2. 3. Okay. So our goal here is for it to print out 2, right? But because of the lifecycle, we're actually going to print out the first one. So I'm going to go detailedly explain this, why this happens. So set persons schedules a state update and tells React that the component needs a re-render. So what schedules means here is that after we finish running our JavaScript, we will then re-render the component. So the second line, which is console.log, it runs immediately with the old person's state. So the state still hasn't been able to be updated because that happens with the rerun. Does that make sense? Okay, and then so this function testing stuff finishes executing, and now the component re-renders from the trigger that is the state being changed, and we need to now re-render the component. So when we re-render the component, we run with the new updated states. So does that make sense? And this reveals a flaw with how we need to be able to access, like, for example, here, we're not going to be able to retrieve the most updated state. And this gives us some reason why we have this next hook that I'm going to describe. So how can we choose to actually something to run after a state does change? So on our new re-render, we want something else to happen. And this is when we have our use effect hook. So use effect hooks run after specific variables change. In other words, it runs after a re-render when we have the updated change. So this is typically used to synchronize something external. So if you're loading data or you're calling an API, at specific times, we use effect. And this is very, very important because if we don't use the use effect, every single re-render will just be calling that function over and over again, which is not something that we want typically. So this is the syntax. We use effect, and then the function that is called every single time a variable in that dependency array changes. So I'm going to go over some examples here. When do you guys think, or in this use effect, we have my function and the dependency arrays, variable 1 and variable 2. So when do you guys think this function is called? Does anyone have any idea? Yes. Yeah, okay. That's basically it, but also we have what we remember from the beginning, during our mounting, we have our initial renders, and that one also runs the use effect. So this this function calls after the initial render and every time variable 1 and variable 2 change. But if any other variables change and we're re-rendering it, we will not run it. So that's very important. How about the second one? We have an empty dependency array now. Anyone? Okay. Since there's no other variables in the dependency array, that means that we just call my function after the initial render, so on mount. And this final one, does anyone have any guesses? There's no dependency array at all. Okay, I'll just tell you guys then. This happens at every single render. So this one, regardless of what state changes are made, it's always going to run this function. Note that any variable can go into a dependency array. It doesn't have to just be a React state. So use effect lets us respond to a state change. So here, when we log it, now we know for sure that our state is fully updated to what it's currently being when we console.log it. So the issue with console.logging inside the testing stuff is because we haven't actually triggered the re-render with the new updated state. So now, when we console.log persons, we will have what we want. So with the me. So let's go into depth about how the use effect works. So we have that function in the curly braces right there. And then within there, we have this return statement and then also this arrow towards this final thing, which is what we have for when the component dismounts. So this is our cleanup function. So if you ever need to exit like an external service, you disconnect. Yeah, like for example, if you're writing data to a database, it can be for closing a socket connection, which we'll later also talk about, but that's the general usage of that. So it can be any function in the cleanup function as long as it's defined. So remember here in our life cycle, this refers to our dismount, and that's when that function runs. So any questions about that? I know it's a little bit confusing with how each of the hooks work within the life cycle. So if you have any questions about how use effect or use state works, feel free to ask. It's 250. I'll go over some common patterns in React, and then we'll end it there. So first, we have conditional rendering, something Skippy was talking about. We'll be like concisely describing it. So to review, we had a way of writing HTML onto the page just from the JavaScript using JSX. And we can define these variables and then call them actually in the return. So this is an example of conditional rendering. And does anyone have any idea of what this code might be doing? Back there? No? Over here? Yeah, perfect. It's gonna show the loading, as he described, when it's actually loading is true, and then when it's false, it's gonna do everything else. The ternary statement, if it's a little bit confusing, just think about it like this. Is the condition true? And if the result is true, then we'll put the thing on the left. And then if it's false, then I'll put the thing on the right. We also have an ability to make it more concise. So you saw before we had like 2 whole blocks of conditions. And rather than doing that, we are just going to put the condition for the exact place where we actually have a difference. So if you saw from before, the title is still going to be the title, and we're still using our paragraph tags. So we can move the condition within the paragraph tags so that it's just when loading is true or false, we have the text for loading being different. Yeah. Oh, loading here is like a self-declared state. So like we have a state. We didn't have like it up here, but just think of it as like, oh, we have loading and set loading equals set state true or something like that. So that's a self-declared state. Yeah. Any other questions? Okay. That's conditional rendering. Second, we're going to talk about rendering on an array of data. So to recap, we need a simple way to map this data to HTML when we have an array of data. And map reminds us of this useful function in JavaScript called map. And what this does is creates a new array by applying the callback function. So we talked about this earlier. So it should be a refresher. We had the Celsius to Fahrenheit example where we just map every single value in the array to the new Fahrenheit value. So how will we use this in React? With this array of objects, React can't just render that. So we want to use a map to apply a callback function to something we can actually display. So, wow, a lot of arrows. Yeah. So here, item.name is the actual thing we're going to display. So we're mapping using this a callback function for the specific item.name. So this in code would just be like this. Might be a little confusing at first, but basically what it is that we have our item in our data, and for each item, we return the actual display. So here we have the item.text. But we use this item.id because, as a side note, if JSX objects are keyed, then React doesn't have to re-render everything when one item is changed. So it's a way for JavaScript to track each of the items so that it like makes it more makes it more convenient, and we don't need to re-render, which is takes more time and space. So what if we have this? What do you guys think this code is doing? We have item component. Anyone have any guess? Okay. What this is doing is we are rendering a component for each data item. So we're running the item component for every single one like this. So key 0, we have my food is Doritos. Key 1, we have another text. And this is a concise way to make multiple components run at once using the map function. Great. I think I'm gonna stop it there, and we're gonna do the walkthrough tomorrow morning, first thing. So, thank you guys for today. Thank you for sitting along for all the way till 3. So, have a nice day. Feedback is really, really helpful for us. Even our lectures tomorrow, we can apply your feedback. So, please give any that you want.
All right, while you guys are packing up, I'll just reiterate announcements. So again, homework 0 for Thursday's lecture. In order to follow along, make sure you have MongoDB set up. So I guess you have today and Wednesday to get that taken care of. But what you do have to do today and tomorrow is milestone 0. Remember, for this, all you do is create a team and submit 10 brainstormed ideas. Remember, we'll submit feedback on your top 3 ideas. And to actually register your team, go on our portal at weblab.is/portal. And then today, we don't have office hours, but we always have Piazza. Someone will always be checking that, and we'll try and respond as soon as possible. So if you need a team still, stick around after today and just meet new people. And if you do have your team but haven't met them yet, maybe they're here in this room, just stick around and say hi. And I believe recordings from yesterday are up. Yeah, they are. And today's recording will also be up as soon as we get that processed, edited, and posted. So for now, you can look at slides in case you got lost or just want to go over the content discussed today. And that's found at weblab.is/schedule, as well as weblab.is/slides. All right, thank you guys so much.
G